Let's Talk About Pain, a podcast from the Quebec Pain Research Network. In each episode, we discuss the latest advances in pain research with guests from across Quebec in the health and research communities. Enjoy your listening.
Okay. Hello, and welcome to this new episode of Let's Talk About Pain. My name is Roseanna Rought. I'm a PhD candidate in the labs of Professor Terence Coderre and Alfredo Ribeiro da Silva. I research the role of intracellular G-protein coupled receptors in persistent pain. So after experiencing complex regional pain syndrome, otherwise known as CRPS, as a teenager, I became fascinated with the understanding of the molecular mechanisms underlying chronic pain. So CRPS is a chronic pain condition, and this affects over 250,000 North Americans per year. It is a disorder marked by severe, disproportionate pain that usually affects the limb, often after an injury, and symptoms include intense burning or throbbing pain, changes in skin color or temperature, and swelling. CRPS can significantly impair mobility and quality of life, and poses challenges for diagnosis and management. So today I'm joined by my supervisor, Professor Terence Coderre, to talk about his extensive knowledge of CRPS research and the wider field of chronic pain. So hello, Terry. Thank you for joining us today. Please can you introduce yourself?
Hello, and hello to all listening. Bonjour à tous. I'm Terry Coderre. I'm a professor that's a member of the Alan Edwards Center for Research on Pain, as well as the Director of Anesthesia Research in the Anesthesia Department at McGill University.
Thank you. So first of all, can you describe CRPS and explain the difference between neuropathic pain, CRPS1, and CRPS2?
So CRPS has a lot of characteristics that are similar to neuropathic pain. There's allodynia, particularly to touch and cold, and sometimes to heat hyperalgesia. But what differentiates it from neuropathic pain is that there's often there's vascular symptoms associated with it. So patients will go through either what's called a hot phase, where their limb is really swollen and red, and that can transition later into a cold phase, where the limb becomes kind of cyanotic and looks a little bit bluish, like there's not enough blood getting into the limb. So it's these vascular symptoms that really differentiate it from neuropathic pain. It can have associated nerve injury with it. If there's injury to a major nerve, we call it CRPS2. If you can't detect injury to a major nerve, it's called CRPS1. Another thing that makes it different from neuropathic pain is that neuropathic pain is usually in the dermatome of the nerve that's been injured, so that we call it neuropathic pain because there's an injury to a nerve. And so you might say that 2 or 3 fingers on a hand are affected by neuropathic pain because they're in the right dermatome, and it stays that way for the whole time that the patient suffers from neuropathic pain. But with CRPS, it's often called that it comes in either a glove-like or a sock-like distribution that doesn't follow dermatomes, and it may spread. It may start in one finger and then end up being the whole hand, and then eventually the whole arm. So that's how it's different.
Great, thank you. So could you tell us a little bit about how the theories to explain the mechanisms of CRPS have changed over the time you've been in the field?
Yeah, so an interesting thing about CRPS is that it has many, many different names over the years, and I'm not going to go through them all, just maybe talk about a couple. One is shoulder-hand syndrome, another reflex sympathetic dystrophy. The names kind of reflect almost the person who studied it and what field they're in, whether they're a neurologist or a rheumatologist, or depending on who the patient sees, they think of it in different terms. So reflex sympathetic dystrophy was a syndrome name for it for a very long time. And it sort of drove the research and treatment of the disease for a while. The idea was that the patients had something called sympathetically maintained pain, which meant that the sympathetic nervous system was hyperactive or something, or chronically active, and re-triggering pathology in the area of the injury that would somehow create a vicious circle that was underlying the pain. So now that shifted at some point because people started to look at, what really happens to the sympathetic nervous system in these patients. And in fact, it was discovered that rather than having a hyperactive sympathetic nervous system, at the beginning of the syndrome, they tended to have a suppressed sympathetic nervous system. So this is what sort of motivated the change in the name. So instead of calling it reflex sympathetic dystrophy, now it's called complex regional pain syndrome. Complex because we really don't understand what causes it. Regional because it doesn't stick to one dermatome. And obviously it's a pain syndrome.
Great, thank you. So can you discuss how you first started researching CRPS?
So I went to a meeting in Denmark many decades ago, actually now, I guess. And Ralph Barron, who is kind of one of the leaders in clinical pain research of CRPS, although we called it reflex sympathetic dystrophy at the time, was there. And he basically made a statement during his clinical talk about CRPS saying that there's really no good animal models of it. And it just got me thinking, and I started to think back of some of the research I did as a PhD student. And I remembered a paper that I'd read by Hans Selye that I thought might give me a clue as to how I could develop an animal model. I searched and searched for that paper and I couldn't find it, but I did come across another one of his papers. Hans Selye is a famous old researcher from the 40s and 50s here in Montreal. Actually, he wasn't a pain researcher. He was more involved with stress research. He's actually called the father of stress research. But anyway, some of the things he did caused inflammation to animals related to the stress. And one of the things he did was put an elastic band around a rat's ankle and left it there for about 3 hours. And when he took it off, the animal's paw was swollen like crazy. And I saw a picture of this in one of his articles. And I said, that looks like a CRPS limb when it's in the hot phase. And so I started to dabble with that, and we played with it a little bit and tried to get it to be a little bit more systematic than an elastic band using O-rings and such. And that's how we developed the model.
Great. So can you talk a bit more about this pain model that you've developed to study CRPS and how it is similar to clinical CRPS?
Yeah, so the other thing that kind of motivated me, it got me really interested when I saw this paper by Hans Selye is that this the procedure he used of 3 hours of ischemia, putting the elastic band around the rat's ankle, so it cuts off the blood supply to the animal's foot for 3 hours, which produces what we now know is called, I don't think he knew at the time, but we now know is called an ischemia reperfusion injury. There is a whole bunch of physiological facts that we know about ischemia reperfusion injury that we then can sort of discover potentially mechanisms that may lead to to CRPS if it has parallels with this ischemia reperfusion injury. And not only did the picture look interesting, I mean, Hans Selye wasn't a pain researcher, so he didn't study it from that perspective. But when we started to look at it, the animals developed clinical symptoms that were very similar to CRPS patients, with tactile allodynia, cold allodynia, occasionally heat hyperalgesia, the inflammatory syndrome where they start out in a hot phase and then they shift later on to have a very, very cold limb that's cyanotic with poor blood flow. So and this matched a lot of the clinical literature that had been developing over the years, especially after people sort of started to drop the idea that, it was a hyperactive sympathetic nervous system, that maybe there were other factors involved. And so we started to look at all the factors that are related to ischemia reperfusion injury as being possible roles.
What other clinical syndromes are similar to CRPS, and what can we learn from them?
Well, so I already talked about ischemia reperfusion injury, but there's another syndrome that's sort of related, and that's something called tourniquet shock. Tourniquet shock is what happens when someone has a limb that's had the oxygen supply cut off for a long period of time. If that happens, for example, someone has some machinery caught on their limb, and the emergency team comes to rescue them and sees that it's been on, and asks them, how long has your limb been cut off from its blood supply? If you're told that it's been many hours, like 12 hours or something like that, you have to seriously consider that you have to take the limb off rather than try to rescue the person, lift the, whatever it is that's trapping their limb and take it off. And because if the blood supply that's in the limb gets into the systemic circulation, they can go into what's called tourniquet shock. Then they can develop what's called a systemic inflammatory response syndrome, which actually can cause kidney damage, heart damage. It can kill you. So tourniquet shock and systemic inflammatory response syndrome can kill you. But there are people who have studied CRPS for many years, clinicians, that have actually called CRPS a localized systemic inflammatory response syndrome. And that's kind of the way I look at it once we developed our model and started to look at what happens with this ischemia reperfusion injury in the limb. Now, another syndrome that's important to consider is something called compartment syndrome. And compartment syndrome, actually the biggest cause of compartment syndrome is fracture, and the biggest cause of CRPS is fracture. When you have a fracture that leads to compartment syndrome, it produces conditions in the compartment, in a muscle compartment usually. Muscle compartment is just the area where the fascia around that holds the muscle fibers all together. There's too much fluid in there, and the fluid starts to create pressure inside the compartment, which then eventually sort of affects the blood vessels in the compartment, kind of compressing all the blood vessels in the area. So in a sense, it produces like an ischemic injury, sort of like putting on a tourniquet. And then once you relieve the pressure, if it's been long enough, you can have an ischemia reperfusion injury. So they're similar, and it could be that many times CRPS is driven by, not necessarily by tourniquets as we do it in the animal model, but by minor compartment syndrome-like effects that kind of relieve quick enough that you don't have a serious problem like tourniquet shock, but that you produce a localized inflammatory response syndrome.
Thank you. So how was CRPS treated in the past, and how is it treated now? And what has been the impact of your model on the current treatment?
So when people called it reflex sympathetic dystrophy, that kind of drove all the research in the area, and it also drove all the treatments. So people were often being given sympathetic blocks, either with a lidocaine block into their sympathetic ganglia. Sometimes they were given a treatment like guanethidine, which produces a chemical sympathectomy, or they would be given a surgical sympathectomy. And sometimes this would be helpful for patients, but other times not. Generally, it would be more helpful for patients who were in the cold phase once they had poor circulation in the limbs, and it could kind of help with that syndrome by blocking the sympathetic nervous system, because sympathetic activity tends to reduce blood flow. So if you already have poor blood flow in your limb, that can be helpful. But it doesn't necessarily mean it's the pathology that's underlying the disease. It could be just that you're relieving symptoms, and so often people would get multiple blocks over and over and over again, and the idea was to try to break this vicious circle that people were calling that happens with the sympathetic nervous system. Personally, I think it's more that you're just relieving symptoms by increasing blood flow, and that it's more of an ischemic problem rather than a sympathetic problem. Now, what's changed with our model is that people are starting to really think about all the potential treatments that could be used if you think that this thing is similar to an ischemia reperfusion injury. So you can look at trying to reduce the development of oxygen-free radicals. So things like DMSO or even vitamin C people have been giving to people who potentially could develop CRPS after a fracture and find that it reduces the incidence of CRPS after fracture. Or you could target things like cytokines or go after endothelins and a number of other targets that we know from the literature on ischemia reperfusion injury that it's involved after you have this kind of an event. Now, it's takes time before theories and animal research gets into the clinic. So many patients are still getting a lot of things that are a lot of the same kind of treatments that are used for neuropathic pain, and we just hope that more and more people will look at this as potentially a vascular problem as well as a nerve injury problem.
Have you performed any studies aimed at translating from the bench to the bedside?
Yeah, we initially, when we first started to do this research, and we discovered in our animals that they had really poor oxygenation of their tissues, we use this instrument called a near-infrared spectrometer, which is actually often used to look at sort of brain tissue, whether your brain tissue is deep brain, can be affected by an injury, and that you have low blood flow in parts of your brain. It's often used in anesthesia to make sure that nothing's going wrong during long-term anesthesia. But it can also be used to study deeper tissues just in limbs, so rather than just look at the oxygenation of skin, you can actually look at oxygenation of muscle. And we showed in some studies that CRPS patients do have, at least a number of them have serious poor oxygenation of their tissue that can be picked up with the near-infrared spectroscopy. We also tried to develop medications, topical medications that are used to try to enhance blood flow to the limb. Not only what we call thermoregulatory blood flow, which sort of warms up the limb, but also nutritive blood flow, which gets the blood into capillaries where we think the real damage is that may be leading to pain associated with complex regional pain syndrome. So we've been doing that research in animals, and we're trying to translate it and get it, get patents and people to license it so that they can develop this for clinical use.
Great, thank you. So is there anything else you'd like listeners to know about CRPS, animal models, or your work in this field?
Well, I think there's just a lesson that needs to be learned, that when we name a syndrome and when we think about a syndrome as being caused by a particular mechanism, that we really have to, and when we're developing animal models, that we have to look at the patients, what information comes from the patients to sort of develop our theories and develop our animal models so that we're not stuck on one thing. So for decades, people were doing only, studying only the sympathetic nervous system and treating these patients with only treatments that affected the sympathetic nervous system without thinking about all the other symptoms that they have that were, say, similar to compartment syndrome, similar to tourniquet shock. And these symptoms really should have been telling us that there may be other underlying pathologies that we have to look at besides the sympathetic nervous system. So I think that's the important lesson to learn from these kind of things.
Great. Yeah, that's definitely something very important to keep in mind. So thank you very much, Terry, for participating in our podcast. Thank you to our listeners for tuning into this episode of Let's Talk Pain, and see you soon.
Thanks, everyone.
Thank you for listening to Let's Talk About Pain. Don't hesitate to subscribe so you don't miss an episode, and to share the podcast with your friends. For more information, visit our website at qprn.ca or our YouTube channel by searching Quebec Pain Research Network. See you next time.